Hello everybody, welcome to the 10.4 video, which where we're starting properties of logarithms and practicing with properties of logarithms. And we're going to be doing something called the change of base formula, and we're eventually going to be able to expand and condense logarithms to eventually help us with equations. So first thing, this change of base formula. If you think about your calculator, the only buttons you have are ln and log, which you assume is log base 10. So if you don't have something that's log base 10 or you don't have something that's just log e, then you have to use this change of base formula. Let me give you an example. If I gave you something like log base 2 of 10, if you think about what we did on past videos, that really means 2 to the what is 10. And 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So we skip right over 10. And so this is not easier this way. So we're going to be using the change of base formula. And so let me show you what this really looks like in terms of a couple problems. If I gave you log base 3 of x, the change of base formula says that you would take log base of the base you want of the argument over log base b of your base. So in our calculator, we can choose to either do log base 10, which is just written as log, or we could even do ln instead. Both of these are used interchangeably, and you could use either one. So to give you a couple of examples, if I give you log base 3 of x, you could do log base 10 of the argument x divided by log base 10 of 3. If you plug that in the calculator, if we knew what x was, we get an answer. If you want to do the natural log instead, it'd be ln of x over ln of 3. In this example, it would be the log base 10 of 4.7 over the log base 10 of the base y. Or if you'd prefer natural log, it would be ln of 4.7 over ln of y. So what I mean by interchangeable is literally you get the same answer from this and from this. It just depends on which one you like to work with more. So to actually apply this to something where you can use your calculator, let's say we wanted to find log base 20 of 175. If you think about this first, what you're really trying to do is find 20 to the what power is 175. But 20 to the first is 20, 20 to the second is 400. So we skip right over 175. So this is where change of base comes in handy. So let's say you prefer log base 10. So we need to change this to log base 10. So that would be log of the argument 175 divided by log base 10 of the base of 20. So if we plug this directly into the calculator, we would get, so we type in log of 175, and we would divide that by log of 20. And if I press enter, I get 1.72. So that means 20 to the 1.724 power gives me 175. While I'm here, let me do ln. ln of 175 divided by ln of 20. Notice that when I do this, I get the exact same answer. So again, it doesn't matter which one you choose. So the answer we got here was 1.724. So that was my exponent that made this true. If I continued with the same logic, I may not use the calculator each time, but this change of base would be log of 0.045 divided by log of 4. And this one would be log of 64 divided by log of 1/8. And yes, you could use ln in both situations if you'd prefer. ln. In both cases, you get a decimal answer. This one, my answer was negative 2.237. So that's the exponent that would work. And here, I got an answer of negative 2, which does make sense because if you think about this one in terms of exponents, you're thinking the base to what power is 64. So we know that 8 to the second is 64. And so if I plug into the negative second power, that would cause this to become 1 to the negative second over 8 to the negative second, which is really 8 to the second over 1 to the second, which gives me 64. So that makes sense. Now time for properties of logs. Now, there's sometimes misconceptions with these. Let's see if I can try to make this clear before we go into examples. So if you have a single log of two things being multiplied, that is the same as two separate logs with the arguments being added. If you have a single log of two things being divided, that is the same as two separate logs being subtracted. And so what this really relates to is to the exponent rule, b to the x times b to the y equals b to the x plus y. That if we're multiplying using exponent rules, we're really adding in the long run. And this one is really using the exponent rule, b to the x over b to the y equals b to the x minus y, that when you're dividing like bases, you're really subtracting the exponents, because again, logs are exponents, so that's why that applies. Something I'd like to point out to you here is that these single logs, the single logs only have multiplication or division, and if you have multiple logs, you only have addition or subtraction. Common mistakes with logs is assuming that this works the other way around, meaning a lot of students think that log base a of x plus y. Notice I said that addition and subtraction only happens when you have two separate logs, not one. A lot of students think that this is equal to log base a of x times log base a of y. This is not true. Something else that is a very easy mistake to make is a lot of students think that log of x minus y, which kind of relates to this one, equals log base a of x divided by log base a of y. This is also not true, because again, single logs only have multiplication division. These single logs have addition subtraction, so that's wrong. Multiple logs only have addition subtraction. These multiple logs have multiplication division. These are incorrect. If you use those would be, I guess, technically illegal, so please be careful. There's also one more property called the power property, which says that if you have log raised to a power, you can bring that power down front, and it is the same as the power times the log. And that one comes in handy quite a bit as well. So let's get started on some expanding. So we're trying to go from one single log to multiple logs. So when you see the word expand, you're trying to go from single logs to multiple logs. And so if you have a log of a multiplication, if we look back really quickly, if you have a single log of a multiplication, that is the same as two separate logs being added. So this is the same as ln of x squared plus ln of y to the third. So we've expanded it, but we're not done yet because we can use this power property. Whenever you have exponents attached to a log, you can bring both of those exponents down in front. So I would say the final answer for this is 2 ln of x plus 3 ln of y. And these are not like terms because the arguments here are not the same, so that's my final answer. In the second example, we have a single log of division. So if I look back, a single log of division is the same as two separate logs being subtracted. So we could write this as log, and you're assuming log base 10 of the square root of x minus log base 10 of y. Now it looks like you might be done because it looks like you don't have any powers, but we actually do, because this can be rewritten as log base x to the 1/2 power, because square root is the same as 1/2, minus log of y. We can bring the exponent down in front, so 1/2 log base x minus log base, or log of y, is my final answer. So I correctly expanded both of these expressions. The other way, especially this example, can be more confusing. So let's not worry about the 1/5 yet. Instead, I would like to focus inside here. And I'd like to focus first on these two logs. I notice that I have two logs that are being added together, two separate ones. So if I have two separate logs being added, that is the same as a single log being multiplied. So what I'm going to do is focus on these two first. But before I do that, I'm going to bring this exponent back up, because when we're condensing, we want to make everything smaller, more compact. So I'm going to leave the 1/5 out here. I'm going to write this as log of x plus 2 to the third plus log of x minus 5 minus log of x squared minus 3. And so if I focus only on these two, we can combine these two together to a single log. And when I have two separate logs being added, I'm really multiplying my arguments. So again, if you look back to this, two separate logs being added is the same as a single log of two things being multiplied. So that would be the same as x plus 2 to the third power times x minus 5 minus log of x squared minus 3, all with the 1/5 in front. So I went from 3 logs to 2, but now we can go from this log and this log, and we can combine these two to be a single log, because even though this argument is complicated, whatever's in here is complicated, we are taking a log minus a log. And again, if you think back to your rules, if you have two separate logs being subtracted, that's the same as a single log of the two things being divided. So if you go back to that problem we were working on, we can write this as log of the first argument, which was x plus 2 to the third times x minus 5. We can divide that by the second argument, which is x squared minus 3. So now we went from 3 separate logs to a single log, and all of this still has the 1/5 on the outside. Now, according to the power rule, if we'd like to continue condensing this 1/5 is going to come to the top. So we'd have log of x plus 2 to the third times x minus 5 over x squared minus 3. We would raise that to the 1/5 power. Now this 1/5 really only applies to everything inside the log. And 1/5 power, again, really means to the 5th root. So another final answer could be log of the 5th root of x plus 2 to the third times x minus 5 over x squared minus 3. So the log always stays on the outside. If there's anything to the power, that power only applies to the argument of the log and not the actual log itself. So that would be our lovely final answer. And yes, we will be practicing this idea much more in class, so if there's some parts of this that are still confusing, it'll be clarified as we go. The next one, rewrite the expressions in terms of ln of 4 and ln of 5. So what we'd like to do is think of 500 and think of ways that 500 could be written in terms of 4s and 5s. And so when I thought about it, I said, what if I broke down 500? 5 times 100 is really the same as 5 times 4 times 25, which is really the same as 5 times 4 times 5 times 5. So one way we could rewrite 500 is 5 to the third, because we have 3 5s, times 4. So I could write this as ln of 5 to the third times 4. And ln of two things being multiplied is really the same as ln of the first plus ln of the second. And so from there, the 3 can come down in front. So we'd have 3 ln of 5 plus ln of 4. And so we're using our properties, and this is one possible correct answer. The reason I say one possible is there's other ways to split 500, but that is an excellent way to leave your answer. The next one, ln of 5 over 2. I'm thinking we could rewrite that one like this. We already have ln of 5, but 2 could be written in terms of 4 because 2 is really the square root of 4. So we could write 5/2 is really 5 over the square root of 4. And if I have a single log of division, that is the same as the log of the first minus the log of the second, which was log of the first minus ln of 4 to the 1/2 power, which would be ln of 5 minus 1/2 ln of 4, because the power, if we are non-condensing, comes down. And so that would be my answer in exact form for the second one.